Doctori, tutto a post, welcome back to a new episode of Sane C++ Libraries. For the ones that may not know what it is, Sane C++ Libraries is a set of platform abstraction libraries for macOS, Windows, and Linux that focuses on fast compile times, being bloat-free, simple and readable, and easy to integrate, with no use of the C++ standard library, and there are also no third-party dependencies. So take a look at the project if you like on GitHub. It's you can look for this URL or just search Sane C++ libraries. And so let's go into what we would like to be doing today. So if you have been able to watch the previous episode of Sane C++ libraries on YouTube, what we have done has been creating this small SC example app, which is just an IAM GUI and SOCL application. SOCL is the graphics and platform abstraction layer that creates the window on multiple platforms, and IAM GUI is the library that takes care of generating the vertex data to draw the actual user interface. The one and if it's just for that, I guess we are just using a couple of libraries. And by the way, this is an example, so these libraries are not needed to build anything of Sane C++ library. So this is just an example. But why have we been building such example? I've been building that example because I wanted to show how you can make a GUI application in that case that is, for example, let's say running but pausing when there is nothing to do for it. So if I'm just now pausing it, like I'm not moving the mouse, this is going in the pause state, and there is no CPU usage, as you can see. But if I start moving and interacting, you will see some CPU usage. Of course, this is just the vsync that is taking 8.3 milliseconds because for a simple window like this one, IAM GUI is actually really fast. So, but anyway, so what I would like to do today is adding and integrating the Async IO event loop such that when you push something into the async event loop, the completion callbacks will be called in the context, in the same thread that is running the GUI, such that the callbacks can be modifying, for example, some shared state with the GUI without really caring about having problems with multi-threaded design. So it will be basically, there will be no need for threads or for mutexes or things like that. So where do we start? Let's try to do something very simple. I have just started doing a minimal reorganization of the code from the previous video. Maybe added, I think, a couple of controls and a couple of constants, but it's more or less the same thing. I have created this model data and model behavior classes. In the model data, there is just the data. It's a pattern that I will probably expand on in some future video. But anyway, this is like a pure data model, something that can be serialized to the disk or to network if you like. And we have the serialization library for that. And then there's the model behavior, which in this case contains the model data. It may just be taking a reference to that, but this is really where the behavior of the system is being built. So this is, for example, where you could be storing the async event loop, which I can declare here, event loop. Of course, I need to include the async library. So I have my async event loop. Yeah, this succeeded. I can create it. Event loop create. And I can close it. Event loop dot close. I will always try it. The sc try macro is just doing like a short circuit such that it will return when there is an error returned by the function that is wrapped into the parentheses. Now let's try to do the simplest possible thing first. So I would like to create like a timeout, for example, async loop timeout. event loop timeout. And to create the timeout, I can just say start on the event loop that must be created first. So I need to do it later. Event loop, how many milliseconds? Let's do it parametric. So let's say timeout milliseconds equals 2 seconds. Let's say timeout after ms. I don't know. Whatever is a good name for this variable. So we have time milliseconds. We can say model data dot timeout after milliseconds. And I would like to definitely be filling this callback. So let's say async loop timeout result. Shall we place it on the object? Yeah, why not? Let's place it in the private section here. Void on timeout. Async loop timeout result. On timeout result. Yeah. So I have my timeout here. I could be counting the int number of timeouts. Let's say I'm incrementing it. So model data dot number of timeouts. And I don't know, I can format string. Should we? Timeout string. Waiting for first timeout. Waiting for first timeout, and let's say string builder. Oh, we don't have a string builder here. Let's do strings, string builder, string. Yes. Well, we already have the string in the string builder. So I can say model data dot timeout string, and I can format it to be timeout number model data dot number of timeouts. Yeah. Oh, we have to try this, so we have to make this return a result. And I guess this means that we have to say sctrust result here, because we cannot return anything from this callback. I would like to reactivate the request, which means the timeout will be rearmed. It will just continue running. Yeah. And I would like to also change the expiration, sorry, the relative timeout. Is this the public field? Yes. Timer expiration relative time in milliseconds. So yeah, I would like to make this parameter so we can change it. And this is just our model data, basically this guy. Return result true. What else? Yeah, maybe let's make it let's make the parameters modifiable from here. So timeout after milliseconds. Yeah, let me change it also here. Timeout after milliseconds. And we also would like to be drawing the string. So timeout string dot bytes including terminator. That's a lot of typing, but I guess we should be good. So we are creating the event loop, we are creating the timeout. We have a callback for the timeout. The callback for the timeout is just counting how many timeouts we have. It's asking for more timeouts. We are making sure to time out with whatever time we have been given, which is 2 seconds by default. And we just format this string, which we don't, but you know, we don't need, but I guess just to show. One thing that we could be doing is getting maybe the current thread ID, which is IUIN 3064. Okay. So current thread ID, we want to save it here just to make sure that we are actually yeah, I would like to assert this, that whatever is the current thread ID is the same as the thread in which this callback is being invoked, because otherwise this is not making sense. One thing I would like to do is maybe add setting the ThreadSanitizer when doing all of this stuff, such that it will help us. Now, but we are not running the event loop anywhere. So where should we be running the event loop? I guess we can run the event loop. We have this run step inside so-called app where we are doing all of this fanciness that is pausing the application when there is no input, and that keeps it redrawing for this number of milliseconds after the last event. So after there's no more input, it will still wait for this, what is half a second, so 500 milliseconds, and then it will just stop here in so-called sleep. One thing we could do is just say event loop dot run no wait. Run no wait, it's similar to libuvu. I think it's called UV run with no wait. There is a flag somewhere, and it's checking and dispatching events on the event loop, but without blocking. So if there are no events, it will just immediately return. So this should make our timeout work. Let's try and see. So yeah, this is not really good. The timeouts are going way too fast, and we are also, this is even stopping, as you see, when we are pausing the input. Before solving the problem with the pause, because that is the actual real meat of this video, I would like to understand why this is going so fast. Timeout should be 2000 milliseconds. Why is this going so fast? We have timeout after milliseconds. Event loop start. Oh, because I was writing the wrong variable. It's not the continue drawing for milliseconds, it's timeout after milliseconds. Let's see if we got rid at least of this bug. So I have to keep moving the mouse for this to work. Okay, well, it's moving every 2 seconds. We can make it move every 1 second. Let's try it. 5, 6, 7, 8, yeah, or every 5 seconds, for example. So this will now stay at 11 and it will become 12. Now it will wait 5 more seconds, and yes. So this works. So the problem now we need to solve is how do we make the event loop, the IO event loop, still somehow work even when the application is paused. We don't want to give up on this fancy way of pausing the application, that is saving CPU time, and it's, you know, it's environmental friendly. We have to do something that is not so simple. Let's say we create a class for that I'm just for now prototyping it here, but I guess this will need to go in the async library. We would like to create a class that is called AsyncEventLoopMonitor that, guess what, will be monitoring the event loop. So in the fields that this library should have is definitely needs a reference to an async event loop. And maybe this needs to be a pointer because we want to initialize this with a create method, not with a not with the constructor. So null ptr. If you remember a couple of videos ago, I've created this async kernel events. So this is the video where things now are getting all together, you know, putting together I was planning for this video I've been planning for this video for a long time. Hopefully I'm able to do it till the end. So this is async kernel events. So what is this object? This object is something that allows us to save kernel events from a async event loop run. It needs some baking memory, so we can do char events memory to be 8 kilobytes. We can make it this as big as we want. It doesn't really need to be a dynamically allocated thing because this is basically just how many events in a given run we are taking off the kernel. So 8 kilobytes is enough. You can make it 16. You can make it anything you want. You can even make it configurable, I guess, but I don't think this will change much. So this is a uint 64. We need to align it. Okay, let's say we have a create method. In the create, we want definitely an event loop. So our event loop is the loop. Maybe we can do some sanity check and see try MSG that event loop must be different. No, must be equal to null ptr. Already initialized. Result close. I don't know, what should I do in the close? We'll see. Return result true for now. So in order to monitor this event loop, I need to create a thread. Why? Because if I have the main thread, and we can see it, that is blocked when this is in pause. So let's make this pause and let's break it. Where is pause? Okay, we are in so-called sleep. The main thread is blocking, depending on the operating system, on a different call, but you know, it's just blocking. It's waiting for a GUI event. So we cannot do something in parallel here in the same thread. We need another thread. And if your intuition is right, and my intuition is right, we need a way then to signal this main thread that is sleeping that it needs to continue the execution. So we will need like a so-called wake up in this case. But let's go back to what we were trying to do. So I would like to create a thread. So I make a thread, event loop thread. All of these objects are objects that are native to the Sane C++ libraries. So that's also a good occasion to really make it, to really see if this is working properly. Let's say I'm making thread thread, and SC trust result monitoring thread. Yeah, this looks good. So our monitoring thread can be result monitoring thread. We are missing something. Oh yes, this one. Ignoring return value, yes. Return true. We want to set the name here, let's say, and this will be useful later. You will see, because it's when creating threads, I always think it's a good idea to give it names, so that you know where you know if something is going wrong. Even ThreadSanitizer can tell you the name of the thread, I think, if I remember correctly. Event loop monitoring thread. Okay, so what should we be doing in a monitoring thread? We have a loop while we are not finished, and as we will need to modify this finished concurrent you know, from the main thread at some point. For example, when closing, this needs to be an atomic variable. Finished. So we have to do load while not finished. While not finished, the main operation we need to do here is event loop blocking poll with the kernel events. So you see where the kernel events comes into play. If not result, return result. Of course, as is, this will not work because we need some synchronization. We cannot be in the blocking poll in the same time that we are either, you know, starting something or we are dispatching some callbacks. So, but we will see. Here we need another method. Conceptually, we need two methods here, like one that is called, I don't know, start monitoring, and another one that is called stop monitoring and dispatch callbacks. Just stupidly long names sometimes are good, in my opinion, because, you know, what is this function doing is stopping the monitoring and it's dispatching the callbacks. We could probably split it into two functions, but yeah, for simplicity, let's keep it in one. So start monitoring should be giving a signal to the monitoring thread to start monitoring, so entering the blocking poll. How do we do that? We need a synchronization point here. To do the synchronization point, we can use an event object. So this can be event loop enter blocking poll, for example. So we can wait here and we can signal this here. This probably will not need to fail, so we can make it void. And this one return result true for now. So What else should I be doing? Well, I definitely need an event here for the user. Function void on new events. So I need to call this function from here such that I can say to the caller, hey, I have new events. And this is where we will need to be unblocking potentially the GUI event loop. But we are missing still the implementation of this one. Let's try to do something simple, and on a very simple level, what we need to do is event loop dispatch completions with the async kernel events. Okay, that's what we need to do. And the integration in client code should be here. So when we are normally drawing, we can just do the run no wait, and it will be fine. But when we will not be, well, let's do it like this. But when we will be doing the sleeping, before sleeping, we need to take our fancy event loop monitor, and we need to start monitoring such that at some point we will be able to know when there is a new event, and we will know it with the on hooking in the on new events. So let's say event loop monitor dot on new events. This is where we need to do the so-called wake up function that does not exist yet. But let's say we have this magic function, so so-called sleep will be unblocked. Of course, here we are in the background thread. And we can dispatch the completion. So you see the trick. I'm monitoring, I'm sleeping. When something arrives, this will unblock, and I can just dispatch the callbacks. So the callbacks will be invoked from here, which is the main thread, and everything is good. Everything is green or pink or whatever color you like. Now, this is starting to look good. I'm just thinking, well, let's try to prototype the so-called wake up, because until we at least prototype that, we cannot even debug. I'm sure this will not work, but you know, if we don't have all of the pieces in the right spot, this is not even starting to become even feasible to debug. So so-called wake up. For this one, I need a little help, which I already did. Well, maybe let's add this so-called, this function here. I need a little help. Why? Because I have been searching the functions that are able to unblock any of these. So in the previous video, we have seen how to write this, but these were very simple because this is a single function. Get message is a function that I know since I was 13 years old. And also this one is pretty simple, but for unblocking them it's a little bit more involved. So I have this. This is what I've been coming up with. So we can use an S event on macOS, a post message on Windows. This one I know how to do it, and an X event event with the xsend event on X11 on Linux. So let's start with macOS. I don't know if we will be able to do also the other ones in the video. If it will become too long, I will probably cut it, but let's try. So this is my, basically I'm sending a fake event to the event queue. Now Sokol wake up does not exist because we need to define it here in the header. Okay. So this is just sending an event, creating a fake event, which is application defined, and sending it. You always have some similar function in every GUI system. On Windows is post message, on Linux you can use xsend event. So if you have another GUI system, just make sure to look for functions that are similar to this one. Actually, to find this one, I was searching for post message like on macOS, and I was able to find this post event and how to create the event and so on. Just Google this stuff. This is stuff that is easy to. Actually, you can even prototype maybe the Win32. So we will need the handle to window, and we can say post message VM, I don't know, user +1 or plus whatever. That's it. And on Linux, well, I can just copy this code for now, and I guess I will need to grab the right window and display from, well, I have it here. Yes, that's actually easy. Do we have the window? I think there is. Yeah, I need to look into Sokol app x11.window. Yes, this one. And we can do that because we are in the same file where the implementation is defined, because these are statics. We need a message type, which I also think we can avoid defining one if there is one of these. Of course, we don't want to send a delete window. What is this? VWM state. Oh, it's the state that changes the full screen. Yeah, we can just maybe try to send this, but this will need to be debugged. So how can I do this? SVM state. Yeah, this one. Well, if this does not work, I will need to create an atom, I think it's called, in the X11 to do check if it will not be bringing problems. So we send the event and we flash also on Linux. But for now, we only care about macOS one. So Sokol wake up is called from here when we are in the background thread. So it should be unblocking this. So if you see, every single one of these lines is sending a message that will unblock this other side of the wall. This looks something that we could at least start running. I think there are some edge cases to handle here, and we also want to have some sanity check, like maybe a finished flag. Yeah. So finish dot exchange true. We definitely want to join the thread. I would like also to signal this, otherwise we will be deadlocking for sure. Yeah, this could be enough. Oh, I'm missing one piece. This is we are not doing the, in a couple of videos ago, we have been splitting the run step into 3 functions, but we are not calling the first function, which is the event loop submit request. That's the one we need. And we need to submit request first, and then signal the monitoring to start. Otherwise, we will clearly have an issue, a multi-threading issue. Okay. So start monitoring. Yeah, this needs to be fallible. So we can try it. Run. I'm sure it will assert with ThreadSanitizer. Yes. Member call on null PTR async kernel events. Oh, okay. We have not been setting the memory for the async kernel events. Events memory is events memory. What type is it? Is it just a span? Yeah, we can do like this. Oh, this is private. Okay. Yeah, I should not be doing the bad guy. That is hard coding this stuff. Why is it? Oh, it's an initializer list. This should have the constructor for arrays. These are the things sometimes in C++ I don't really understand. Or maybe it's a uint8. That's why it doesn't convert. I should be reading the messages, but sometimes I'm not. Yes, of course. Now, let's try again. Null pointer of type async event loop. Am I calling the create here? No, I'm not even calling the create. So event loop monitor dot create event loop. Okay. This is working. So I'm actually puzzled because I think there are a few edge cases that should not. Yeah. Is it the the ThreadSanitizer is complaining? Okay, I knew it because this would have been way too. So you look, you know how useful it is, the ThreadSanitizer. This thing is actually kind of working, it's pausing, but every time there is a timeout, it resumes. It actually resumes for like alpha seconds, and then it goes to sleep again. It's actually exactly what I wanted to achieve, but I don't want to achieve it with thread issues. So one thing we can try to do now is asking, there's a data race, create breakpoint. So let's see, we will be stopping when we have one of these threading issues. Yeah, we have one. ThreadSanitizer. Look here. We are in the blocking poll while we are dispatching the completions, which is not a good idea because we are on the blocking poll on the background thread where we are writing the queue of events. In the same time, we are iterating this queue of events in the dispatch completion. So this is definitely a really bad idea and very typical multi-threaded, craziness behavior where, it kind of works, but not properly. And I have already in mind where this is happening, but let's try to see. So the thing is, we should never be in the blocking poll while we are in the dispatch completions. So I would like to put another synchronization point here, because I don't know, once I do the start monitoring, if the user will move the mouse, for example, while I am still in the blocking call because the timeout has not expired yet, so it's just waiting there, I will just go into the stop monitoring and start dispatching completions while this is still, while this is still in blocking poll. So this is clearly not correct. We need another synchronization point with the event object, which I guess we can call exit blocking poll. The exit blocking poll, we can call it here. You can signal it here, so to say, hey, I'm out of the blocking poll. And now you can be waiting for that, such that, when I'm out, you can dispatch your completions. But now we have another problem. I already see it, because what happens if, wait a minute. No, maybe not. I don't know. This kind of multi-threaded stuff is hard, at least for me. Let's try it again. So this is kind of going. So I need to unpause it while it's paused. Yeah. But now I'm not able to unpause it, or am I? Yeah, when it's paused, I'm not able really to unpause it with the mouse. Let's see if I make this 10 seconds. I need one more 0. Yeah. Pause. No. Well, yeah, I cannot really interrupt it. This is frozen. Where am I frozen? I'm waiting for the condition variable. Yes. While my event loop, and you see why we need to be naming the threads so we can find them in the debugger. Yes, while I'm waiting, in the blocking poll, because my timeout is very long, it takes 10 seconds and it's not happening yet, but my user has moved the mouse, so I want to quickly unblock this and eventually, run any completions that may have been collected in the moment. This is clearly not working, so I need to be unblocking the blocking poll from here. So you see there are a lot of edge cases to handle. So from here, I need to be able to unblock the blocking poll in case it's still waiting. To do that, we can use an object that I have already created in quite some time ago. It's one of the first things that I have created in the async library because I know that it's going to be used in this kind of scenario. It's called async wakeup, loop wakeup, event loop wakeup. So we will create the event loop wakeup here. Yes, event loop wakeup start on the event loop. And the event loop wakeup has a callback. This callback is called when it's similar to the libuvu, I think it's called async, UV async, something like that. And this is an object that you can call it as a wakeup method, and you can call it from any thread, and the callback will be instead actually I don't even need to do that. Do I need? Yeah, probably yes, because I need to know if the I need to do it in the callback version, because there is even a version of the loop wakeup that has no callback, which you can call directly on event loop, I think. Wakeup, yes, from external thread. I need the version with the callback because I need to know if this happened for real, because I need to know if my blocking poll had actually events or if it was actually me who unblocked it. Me in the sense of stop monitoring and dispatching callbacks. So that's where we want to call the event loop wakeup dot wakeup. And in the callback, I would like to write some atomic variable. Wake up happened, I don't know. Did wake up. Any name will just work. So wake ups, we can say true. And we can say, no, maybe this does not need to be an atomic variable. This could be just a regular variable. We need an atomic needs wake up, because this one when the blocking poll is unblocked, we don't need a wake up. So we can say that we don't need it. But when we are here, we can check. Needs wake up. So if we need wake up, we wake up. but we also need to check if it actually happened. So let's say wake up actually happened. Because if it actually happened, which we need to reset here to false, I need to consume one more event loop run. Do I? Yes, because the wake up will need to be consumed, because the wake up generates a completion and the completion needs to be consumed, because otherwise in the next cycle the blocking poll will just return immediately, which is not what we want, because it will find the completion for the wake up. So we need to remove it. So we can do run once. Run once is the one that blocks because it expects forward progress. Yes. Let's recap. When we have case, first case, blocking poll, it's unblocking itself because, packet socket event happened, packet on the socket arrived or a file was finally read, and we can say we don't need to wake up. So when we arrive in the stop monitoring, we can say, do we need to wake up? No. If not, we will just do what we did so far, which works well. But instead, case B, if we are in the blocking poll and we arrive here, we want to unblock that thread because we want this also to be unblocked. So we check if we need to wake up. If we need to wake up, we wake up the event loop such that we will unblock the blocking poll, but we also track this flag if the wake up actually happened, because as these are two separate threads, in the exact moment between, when I enter here, the other thread may have just been unblocked. So I'm setting this flag such that I can check if the reason, I don't care if the reason why the blocking poll was unblocked is my wake up or just any other event. I want to know, because if it was some other event, its completion will get dispatched here. But instead, if it was an event caused by my wake up, I need to consume it here. It's like a ref count. You really need to consume every event that you produce. So if you produce the wake up event, you have to consume the wake up event. Otherwise, this will immediately cause a problem here, because in the next cycle, blocking poll will immediately return, which is wrong. The wake up is just a mechanism we want to use to preemptively stop the blocking poll and make it return immediately. This sounds good. Let's try it. Well, this is not compiling. Why? Oh, of course, we need async event, async loop wake up result. Yeah, we probably need to rearm this one. Reactivate request true. All right. Run it. Paused. Running. Paused. Pause it. Pause it. we are still not able to. Yeah. So now this is paused for 10 seconds. Where are we blocking? So we are now into the blocking poll wait. And where are we on the other side? Huh. We are still in a blocking poll. That's interesting. So our wake up is not functioning for some reason. What's going on? Exit block. Well, we definitely need to signal also the exit blocking poll here, but this is probably not the issue. Can you spot the bug? Because I can't. This is something that I was really planning for some time, and in my mind it was pretty clear, but this is not working. So the wake up is not happening. So if I place myself here, not here, where is it? The callback. Are we registering the wake up? Yes, because this is getting registered. Or should I submit it? I don't think it's needed. Yeah, no, this is not working. Well, no, we don't need this for sure. Why is the wake up not happening? Oh, this is happening. We are even reactivating it. Where is this guy? We are still... That's really puzzling me. So the wake up happens, but we are already here in the wait. Which should not happen. Well, once we unblock it, I don't know. I don't know what's going on. Wake up actually happened. So by the moment I'm moving, this is getting cold. Moving the mouse, this is getting cold. So the complete, who's calling this? Dispatch completions. And where is the other guy? Completely puzzled about what's going on here. This is not easy. I knew it. I knew that this will just make me go crazy. This looks correct. Okay, we need to think a little bit about what's going on. So I'm calling the wake up. The wake up should be unblocking this. But this is not happening. I want to see. So once I go here, I should be immediately be hitting the other one. Okay. This should be waiting. That's correct. So it's calling the blocking pole signal. Which will dispatch the completions. Okay. This is getting called. So if I do need wake up, and wake up actually happened. Oh, okay. We definitely want to run once when the wake up was not happening. So maybe that's what we were. No, that's still not what we were trying to do to solve this issue. I don't know. Why is this not working? Needs wake up exchange false. Are we resetting the needs wake up somewhere else? No. So I need this one. Maybe. Okay, running paused. But if I move the mouse, running. Move the mouse, running. Move the mouse, running. Beautiful. Now if I say that the timeouts should do every 2 seconds. Yeah, this works. So you see, okay, we got it. So what's happening here is the application is pausing every time there are no inputs and there is no IO event to be processed. When it's paused, so it's in a blocking call in the main thread, which means that the GUI is blocked into some sort of event loop on the main thread, then the IO event loop, it's rising this function. Of course, we are crashing on exit, so that will need to be fixed. And it's calling this callback which we call on new events, where we wake up the main thread. And on the main thread, after we wake up, which means we go after the so-called sleep in this case, we will stop the monitoring and dispatch the callbacks. We need a little bit of machinery here, which I suspect maybe it will have still some edge case that I'm not able to see right now. But yeah, I was expecting to need like 2 synchronization points and this kind of variables. So this is looking to be working, because I can unpause I can still be unpausing the event loop properly when everything is paused, and the timeouts are just able by themselves to execute. Of course, I need to maybe put it back to a decent value. Where is it? Instead of 10,000, yeah, I'm gonna make it 2 seconds. Yeah. So we can try to see if this is working on Windows. Maybe at least on, and we also need to fix this crash at exit. So are we calling the close? Maybe that's all we need to do. Yeah, there's only event loop close. There's no event loop monitor close. Let's see. Close. Yeah, takes a while, but it's closing. It takes a while because we probably need to do the wake up as well here. So let's also do the event loop wake up dot wake up. Let's try again. Yeah, this is a lot faster now. Cool. Let's try to see on Windows. So on macOS, this looks kind of working. On Windows, hello Windows. Okay, let's start Visual Studio. We have a post message with a user. Well, hopefully this VM user +1 is not used by Sokol. Let's double check. VM user, no VM user at all. That is good. Let's open the project. And I can try to compile it. Okay. Run. I need a faster computer probably. That's not so bad, but you know, faster computers makes you wait for less. Oh, this is not right. Why? Oh yes, because set thread name wants native char. Was it native str? Yes. Run. Yeah. This is compiling, it's encouraging. Running, pause, running. Yeah, looks to have the same behavior as the macOS. So this is good. So Windows is working good. I can try to take a look at the Linux one as well. So let's close this VM. I don't have such a fancy computer that I can keep all of these VMs opened around. Maybe I can start the Fedora. And let me connect to my Fedora workstation. So on Linux, I have, I was trying this VM state. Let's see if this is not bringing any side effect, or probably we should be defining our own event so we don't really interact with anything else. So I can compile SC example. Oh, we don't have a display here. Let's say this is the display. Clock skew detected. Yeah, because when resuming this VM, it's probably better to just delete the intermediates and let it recreate everything from scratch. I should be adding a SC build clean, I guess. Let's see. Linking SC example. Paused, running, paused, running, paused. That's beautiful. And if I move the mouse, it's unpausing. So on all of the three platforms, this is working correctly. It was not really easy, but I guess we kind of did it. So this brings us to the end of this video. We can recap just very quickly what was done. So initially we have started with an application that has just the ability to pause when there is no input, no user input. But this is not enough because we want an event loop where we can schedule like connections, network connections, and file reads and timeouts or things of that nature. And we have many cases to handle because we may be with the GUI being paused and something happens on the IO event loop, and we want the IO event loop to be able to wake up the GUI, or the reverse. Everything is stopped. We are monitoring this IO event loop, but we want to unblock it when input event happens. So I've created this AsyncEventLoopMonitor machinery that uses two signals to basically section and synchronize two threads such that they will be exclusively in one section or the other. So when I'm in this section in the blocking poll, I'm not doing any submit requests and I'm not doing any dispatch completions, and vice versa. The other flags, like the wake up, is really needed when the blocking poll is still in place and an input happens and you want to wake up and unblock the blocking poll. So you do the wake up. You want to check if the wake up was actually being dispatched by the dispatch completion, because if it was not, then you really need to consume it, because if you don't consume it, then the blocking poll on the next run, on the next cycle, it will be immediately be unblocked, and this will not work. You will just see continuously rendering all the time, and continuously, the IO event loop continuously unblocking that causes rendering all the time, which is not what we want to do. So we achieved to create this application that is, using the minimum amount of CPU time in order to keep everything going on smoothly. So, I can even make the continue drawing to 0, I guess. So it will just be waking up for incrementing the timeout. And the CPU time, as you see, is mostly 1% or 0. It's 0.1% most of the time, because the application is waking up just every 2 seconds. Oh, what's going on? It's crashing. No. Oh, sorry. It's just Visual Studio Code that wants to take the focus. I hope you enjoyed the video, and if you like this, please check out the project, Sane C++ Libraries. Get in touch with me or anybody who's already joining the Discord. And yeah, let me know what you think about this in the comments, and see you next time with Sane C++ Libraries. Bye.